All right, in today's notes, what we're going to do is learn how to graph the different conics. We're going to start with the circle because it's more familiar to you. We did it in geometry last year. So the standard form of a circle equation is going to be x minus h quantity squared plus y minus k quantity squared equals the radius squared. Remember, the center of your circle is going to come from the hk values. And anytime in algebra we're talking about taking a point from values that are inside parentheses, the parentheses does the opposite to the sign. So if h is negative like in the equation, then when we talk about the center, it's going to be positive. All right, so for our first example, we notice our equation is a circle, and we're going to grab the center points, and the center is going to be 3, 2, -2. All right, so your directions on top tells us how we want to grade for full credit for your graph. So on circles, you have to identify the center and identify the radius. So we identify the center, we identified the radius. Now we just need to plot our point. And 1, 2, 3, 1, 2. Okay, since the radius is 4, we're going to travel 4 units in the up, down, left, right. And then connect the outer points as a circle. So as long as you have this and this in your circle graph, you'll get full credit for graphing circles. All right, then our next conic section that we're going to look at is the ellipse. The ellipse, since the ellipse is either longer in the side-side position or the up-down position, we're going to call them horizontal ellipse or vertical ellipse. And their standard form is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So this is the standard equation. All right, so in our next example, we notice that this is in the same format for standard form of an equation for an ellipse. And we're still going to have a center for our ellipse, and we are going to get those values from inside the parentheses. So my center is going to be -1, 4. The values on bottom are squared numbers. So if you take the square root of each of those, they tell you how to move from the center. So in the x direction, because 25 is underneath the x value, that means in the x direction, which is left, right from the center, I'm going to move 5 spaces. And then on the y, I have a 16 underneath it. So that means from my center, the up-down movement from the center point is going to be 4. So we're going to graph -1, 1, 2, 3, 4 as the center. And then in the left-right direction, the horizontal direction, we're going to move 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And 4. 1, 2, 3, 4. Okay, and then we're going to connect our outer points into an ellipse shape. All right, so to get full credit for the ellipse graph, you have to identify the center, the vertices, the co-vertices, the length of the major axis, and the length of the minor axis. So we have to kind of define these for you. You know that major and minor is like big and small. So this is big, this is small. And what they're referring to is on the ellipse, if you connect the movement of your x and y direction. So when I'm looking at it, I traveled more in the x direction than I did in the y direction. So this is your major axes because it's longer. This one's going to be called the minor axes because it's shorter. Okay, and then what they're asking for is what are the lengths. So the major one, since we traveled 5 in either direction, the length is going to be equal to 10. And then for my minor, we traveled 4 in either direction, so the length is 8 units. Okay, we also need vertices and co-vertices. So if we go back up and look at this, your vertices are the endpoints for your major axis. So these are endpoints. And the co-vertices are also endpoints, but for the minor axis. All right, so we will have 2 vertices. Right, and we'll have 2 co-vertices. And we're going to label the points from left, right, or bottom up. Right, so on my major, starting at the left, this endpoint, right, is 5 left from the center. So that's -6, same y value. Again, for this endpoint, it'll still have the same y value of 4, and I traveled 5 from my center, -1, so I end up at 4. You can also count it out. And then for the endpoints of my minor, right, start at the bottom. These are going to be your co-vertices. So they all have the same x values of my center, which is -1. Okay, we started at 4 and we traveled down 4, so we ended up at 0, and we traveled from 4 up 4, and so we ended at 8. Okay, so on our next example, we're going to work out another ellipse, and this time we call it a vertical ellipse. So this one was a horizontal ellipse because it was longer in the horizontal direction. This one, when we graph it, should be longer in the vertical direction, like this. Your equation, your standard form of the equation, is very similar to this. The only thing that's different is where I put A's and B's. And that really doesn't matter for us in Algebra 2. And then you'll learn more about that in pre-cal of why we have that as a difference. Okay, so I want you guys to try this one on your own and hit pause now and then come back and check in on your work. All right, so check your work, see that your graph matches and that you have all the required information off to the side so that you can get full credit for graphing this ellipse. Okay, our next conic section that we're going to do is the hyperbola. The hyperbola's standard equation looks very, very similar to the ellipse. The difference is going to be the sign between my terms. So on yesterday's notes, when we talked about how to identify on a random equation if it was which conic section, one of the questions we asked is do they have the same signs for our x squared and y squared term? And if the answer was no, that's how we knew it was a hyperbola. So there is the difference of signs on our x squared term and our y squared term. Okay, so this is going to start off very similar to the ellipse. We're going to get a center point from the parentheses, right? So this is grouped with x, so this is an x value for the center. This is grouped with y, so that's the y value for my center. The bottoms, we're going to take the square root again and travel those distances in those directions as well. So since this 9 square root is 3 and it's underneath the x, that means the left-right direction is 3. And since this one is underneath the y, that means the up-down value that we travel is going to be 4. All right, so we go ahead and we plot our points and we travel the appropriate distances. Okay, we're not making an ellipse though, right? This is supposed to be a hyperbola. So there is going to be a difference in what happens next. This formation that we made is an outline for a rectangle. And it'll always be that way. So right now it kind of looks like a plus sign, but we're going to turn this into an outline of a rectangle, and I'm putting them in dotted lines because they're not really part of my graph here. What these are going to do is help form the asymptotes that the hyperbola function has. The asymptotes are going to come from the diagonals of the rectangle. Okay, so we're going to take a straight edge and we're going to draw out the asymptotes that are part of the graph. Make sure that you are connecting center to your corner vertices there on your rectangle. So we should have a negative sloped asymptote, and we should have a positive sloped asymptote. Okay. So this center point that we've identified is not actually part of either of the curves of the hyperbola. It will be the midpoint of the vertices. So the vertices are going to come from these points that we've labeled, and to know which one of these pairings is supposed to be the vertices, you have to go and look at your original equation and find the squared term that's positive. And this is the squared term that is positive because after expanding on this, this is going to say positive x squared, yada yada. So that means this one is going to form the vertices. So in the left-right direction, these points are my vertices. So I'm going to make them super big so we understand these are my vertices. Now we're going to use the vertex and pull in a curved fashion towards my asymptotes. And that's how the graph looks like. Now to get full credit for the hyperbola, we have to label the vertices. And we also have to talk about the equation of the asymptotes. Okay, so the vertices is not too hard to get. Let's skip that for now and talk about the equation of your asymptotes because it might have been a while. So to get an equation of a line, remember we have two formulas that really help out with that. One is point slope, and that's y minus y1 equals m times x minus x1. And then we have slope intercept, and that's y equals mx plus b. All right, so first we're going to use point slope, and it's really easy to transform point slope into slope intercept. So your final answer should be in slope intercept. Remember, on point slope, your inputs are going to be the y1, the m, and the x1. This y and this x are always part of the equation. They're just there always. So where do we get these values from? So first what we're going to do is use the counting method to find the slope, or look at your values on the bottom. So we traveled in the up-down position 4, which is the rise part. The run part is 3. And since this is a rectangle, they're going to be opposite signs of each other. So on my positive sloped line, it should be 4/3 for slope. And for my negative sloped line, it's going to be negative 4/3. All right, so from there, what we're going to do is substitute using the center point into our point slope formula and the slope that we just gathered. So you have to work out two separate equations. One's going to have a positive slope and one's a negative. So if I work out my positive one first, substitution looks like this. Y minus 3 equals 4/3 times x plus 2. You're going to distribute, and after distribution, you're also going to have to move this negative 3 to the other side so that it will be in slope intercept form. So then it's 4/3 x plus 8/3, and since I have to move this over, and it needs to combine with 8/3, so I'm going to make it positive 9/3 because they need a common denominator. So my equation is going to be y equals 4/3 x plus 17/3. Okay, we're going to do the same thing on my negative slope. All right, so check out your work. Check out that your final equation looks like that, and those are the vertices that we